Hello, my name is Mr. Fontenot, and in this video we're going to be going over the calculations for the Chapter 21 math handout, which is for transformers, and we're going to do problem number 1. And we need our work area set up like this with our math handout, notebook, formula sheet, and our calculator. First thing I need for you to do is pause the screen right now and go ahead and draw your circuit here, which is a transformer. Write out this electrical quantities spreadsheet here and be prepared to write the steps. Let me go to that screen here. Go ahead and write all your steps down and write out this electrical quantities spreadsheet and draw your transformer. And you can pause the video and take all the time you need to do that. Alright, so I'm going to begin here. You see that I have filled in my known values. I had 120 volts on my primary, which I filled in here. It is a 5-to-1 step-down transformer. I fill that in here, and the RL is 12 ohms. So we're going to begin to make our calculations. And I'm going to follow, I've got here my formula sheet, and I'm going to be following my formula sheet, going in order with my formulas. And this sheet here, I have filled in some of the values from this particular problem. So that's the difference between the two there. Alright, so the first thing I need to do, and if I look up here at my steps, the first thing I need to do is I need to find the value of the secondary voltage. And I'm going to use formula number 1 to do that. And it says that the voltage of my secondary is going to be equal to the number of windings of my secondary over the number of windings of my primary times my primary voltage. So I look up here and NS goes first. That's 1. Then I hit over under. Says that NP goes next. Primary windings 5. It's a 1 to 5. I'm sorry, it's a 5-to-1 step down. And then I'm going to say times my primary voltage times VP right here. VP. And that was the 120 volts that I had been given. So it's a 5-to-1 step down ratio. I'm going to expect to have less voltage on my secondary than on my primary. Because if I look up here, I got 5 windings on my primary, but I only have 1 on my secondary. So that tells us it's a step down. I hit equals, and it looks like I've got 24 volts for my secondary voltage. Alright, now that I've got my secondary voltage, I want to find my secondary current right here. And on this sheet it would be right here. So I'm going to be looking for my secondary current. And this tells us that we're just simply going to use Ohm's law. So IS is equal to VS over RL. We just calculated the VS to be 24 volts. It's already in the calculator. But for clarity's sake, I'm going to enter things back in. So 24 volts over my RL of 12 ohms equals 2 amps. So this tells me that my secondary current is 2 amps. Alright, the next thing I want to calculate is my secondary power, my PS, and that's in these locations. So we see here to calculate my secondary power, I just calculated my secondary current at 2 amps. It's already in the calculator, but I'm going to re-enter it just for clarity's sake. So 2 amps times P is equal to I times V. So I need that secondary voltage of 24 volts that I calculated earlier. And this gives me 48 watts because I was looking for secondary power Power is measured in watts, so my secondary power is 48 watts. Alright, if you look at your formula sheet, the next thing on your formula sheet right here says that the primary power is simply equal to the secondary power. So both of those numbers are the same. There's really no calculations. Whatever your power is on your secondary, that's your power on your primary. So he also would be 48 watts. Alright, so I calculated my secondary power, and my primary power is the same value. Now I want to find my primary current. I don't have any resistance over here. I don't have a resistance value, so to find current when I don't have resistance, but I have my voltage and my power, well, I can use my power formula. And that's what formula number 5 right here shows us. That the current of the primary is equal to the power of the primary divided by the voltage of the primary. And I have those numbers for you right here as well. I'm fixing to put them in my calculator. But if we look here, IP is equal to PP over VP. We calculated that our primary power was 48 watts. We were given from the beginning our primary voltage of 120 volts. So if we take our 48 watts divided by our 120 volts, that gives us approximately 400 milliamps of current on our primary. So we can fill that in right here, 400 milliamps. Alright, so that brings us all the way down to formula number 6, and there's a couple of different ways we can get this value, but we're just going to go with 6A right now to keep it simple. If I'm looking for the inductance of the primary, I can take the voltage of the primary, which is 120 volts, over the current of the primary, which I just calculated. The current of the primary is 400 milliamps. 400 times 10 to the negative third, and I hit equals, and that tells me that I've got about 300 ohms of inductance on my primary side. So now you see here that we have found everything. Next, I'm going to do a demo for you, problem number 2. If you look here at our steps, we finished this, then number 6, we finished this. We could also use this formula, but we're just going to stick with the simple one of Ohm's law for right now. If you've enjoyed this video, please leave a comment. Thank you.